Hello everyone, welcome to the solution of LeetCode problem 35 named Search Insert Position. In this problem, given a sorted array of distinct integers and a target value, now we have to return the index if the target is found. If the target is not found, we have to return the index where it would be if it were inserted in order. Now you must write an algorithm that runs in big O of log and runtime. Here, for these examples, the target is 5. So here we can see that the 5 is present in the array in the index number 2. That's why you have to return 2. Now here, we can see that the target is 2, but 2 is not presented in the array. That's why if we insert the 2 into the 1 index between 1 and 3 here, the array will be still sorted, so the index is 1. Similarly, here the target is 7. We have to place the 7 after 6. So here the index is 4. Now, I hope you understood the examples. Now the array length can be in between 1 to 10 to the power 4. And each of the array element can be in between minus 10 to the power 4 to positive 10 to the power 4. Now, array contains distinct value sorted in ascending orders. And the value of the target can be in between minus 10 to the power 4 to positive 10 to the power 4. Now, I hope you understood the problem statement. Now, let's jump into the algorithm. Before jumping into the algorithm, let's try to understand the basics of the binary search. Here, the binary search is, suppose we have to determine whether the value 5 is presented in the array or not. Okay. How can we determine? We have to take two pointers. One is pointing to the first element, another is pointing to the last element. And we have to calculate the mid value. Now, let's calculate the mid value. Here the mid value is 0 plus 5 divided by 2. That means 2. This is the mid value. Now we have to check whether our target element is greater than mid value or not, or our target element is less than mid value or not. Here we can see that 5 is greater than 3. So we can say that the 5 can be found into these positions because all of the value in the left direction of the 3 are less than 3. So that's why there are no 5 available, or it is not possible. So we have to take or find the 5 into this direction. Now it can be possible that suppose we are finding the element 2. So 2 is obviously less than 3. That's why we have to find the 2 into this region, right? That's why it is not possible 2 should be found into after the value 3 because all of the value into this region are greater than 2. So here, the basic intuition of the binary search is if our target value is greater than mid value, we have to shift our starting pointer to mid plus 1. And if our target value is less than mid value, we have to shift our end pointer to the mid minus 1. And we have to repetitively do it and find this value 3 or this value 5. Now, it is the basic intuition of the binary search. So now our problem is how this intuition can help us to solve this problem. At first, erase all of them. Now let's take example. Suppose our array has 3 elements, which is 1, 3, and 5. And the value of target is 2. So here we can see that if we insert the element 2 between 1 and 3, the order will be sorted and index number will be 1 because we know that index number starts from 0. So the index number of 2 will be 1. So here in this problem, we have to return 1. Now we have to check how can we calculate this index number. Now here, at first our start and ending element is here. So the mid value will be 0 plus 3 divided by 2, which is 1. And mid is pointing here. Now we have to check whether the value 2 is greater than or less than mid or not. Here, the value presented at mid is 2. So here, the value 2 is equal to the mid. So here we have to shift our last pointer into the mid minus 1. Now we have to shift our last pointer. So last pointer will also point into this position, so 1. And start pointer is still pointing to this position 1. So here the mid value will be 1 plus 1 divided by 2, which is 1. So, sorry, my mistake. It will be 0 plus 0 divided by 2, which will be 0. Because 0 is the index number here, pointing to the both left and the right pointer. Now, okay, wait. We can see that the value presented at 0 index is 1, which is less than our target value 2. So we have to shift our left pointer to mid plus 1. So now our left pointer will pointing to this element. And here our left pointer is pointing here and right pointer is pointing here. So we have to stop the iteration because the left pointer moves to the right direction of the right pointer. So it is not possible. So here we can see that this index number 1 is the ideal insert position of this element 2. So here we have to return 1. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named search insert. Here, 2 parameters are given. One is a vector, another is a k. Now we are taking 2 pointers, start and end. Now we are performing binary search here. And while start is less than is equal to end, we are calculating the mid value, which is start part plus end divided by 2. Now here, if the value of k is greater than the mid value presented in the array, we have to shift the start index. Otherwise, we have to shift the end index. And finally, we have to return the start index or start pointer. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.